Hello everyone and welcome to the latest installment of the IGCSE 0580 Solution Guide series. In this video we will take a closer look at paper 2.2 from the May-June exam period of 2021. Without further ado, let's get straight into it. In exercise 1 it is mentioned that the probability that Jane wins a game is 7/10, and in part A we are supposed to find the probability that she does not win the game. Since the likelihood between her winning and not winning are two complementary events, we will use the provided formula to determine the likelihood for it, leading us to the probability for her not winning the game being 3/10. In part B it is stated that Jane plays this game 50 times, and we are supposed to find the number of times she's expected to win the game. Our keyword here is expected, and using the formula for expected values as provided, we can determine that she's supposed to win 35 games out of those 50 mentioned. In the second part of this exam paper we are supposed to calculate the value for the following expression, and using our pocket calculators we can conclude, depending on the setting of the pocket calculators, that this value is 2/5, which equals 0.4. So either you will see a fraction, first solution, or a decimal number. Next on to exercise 3, where Emma has 15 mathematics questions to complete, and the stem leaf diagram below shows the time in minutes it takes her to complete each question. The key is provided, the first column expressing tens, and the second column, the larger one, expressing ones. We are supposed to complete the table below. The mode is represented by the number that has the most occurrences within the above diagram, which in this case is 16. It occurs 3 times and no other number occurs as many times or more often than that. To determine the median, we will have to find the midpoint of our sorted list. So to count through quickly, we have a total of 7 values in the first row, another 7 values in the second row, and 1 more value including the final row. Since this is a total of 15 values, the value that is right in between the first and the last one is the 8th value. So counting from the top left, 1, 2, 3, 4, 5, 6, 7, 8, meaning that the median time to complete the question is 11 minutes. Finally, we're supposed to find the range, and this is done by subtracting the smallest value from the sorted list from its largest one, which leads us to conclude that the range is 17 minutes. In part 4 of this exam paper, we're supposed to write down an expression for the range of k consecutive integers, and similarly to the exercise above, the range indicates subtracting the smallest integer from its largest, which is k. Therefore, the expression for the range that we're looking for is k minus 1. Moving on to exercise number 5, where in part A Henrik has drawn his scatter diagram, and we are supposed to put a ring around one correct statement about this scatter diagram, indicating that only one of those 4 statements provided in conjunction with the scatter diagram is correct. In this case, the correct option is the second one, that it is not possible to tell if there's a correlation, as there are not enough points. So more data would have to be collected and plotted into the diagram in order to be able to find a reliable answer. In part B, we will take a look at the 4 scatter diagrams below, all of them representing the same set of data, and a line has been drawn on each diagram. We are supposed to complete the following statement, namely that the line in diagram is the most appropriate line of best fit, which in this case is obviously diagram C, as on average the data points are closest located around the line. Next on to exercise 6, where it is stated that a rhombus has a side length of 6.5 centimeters and it can be constructed by drawing 2 triangles. Using a ruler and compasses only, we're supposed to construct the rhombus, and we should leave the construction marks. One diagonal of the rhombus has already been drawn for us. Firstly, diagonal means that the points at the end are opposite of one another. And in order to determine the second diagonal of the rhombus, which is perpendicular to the other diagonal, we can simply construct the bisector of the first diagonal using our compass. We need to keep in mind that the radius of the compass needs to be at least a tad longer than the distance from one end of the diagonal to its midpoint. Otherwise, we would not get an intersection between those 2 arc lines. The first arc line emerges from using this point as the center of our circle, and for the other arc line the same accounts for the opposite side of the diagonal. From there we can now use the ruler and draw a line through those 2 intersection points that emerged from drawing aforementioned arc lines. Another important thing to keep in mind is that both of those arc lines must have the same radius. So now that we are provided with both diagonals, we need to figure out where the endpoints of the other diagonals are actually located, and we can do this by using this endpoint of the diagonal that was provided and use our compass using a radius of 6.5 centimeters meters since it represents the side length of the rhombus. Drawing our arc from there will provide us with two intersection points with the diagonal that we have just constructed. And those in return we connect with the edges from the diagonal that was provided from the outset of the exercise, namely the dotted line here. Moving on to exercise 7, where in part A we are required to complete the following statements. Firstly, we need to find the reciprocal of, so to find this reciprocal, we can convert the decimal number into a fraction. So 2/10 is represented by 2/10, which can be simplified to 1/5. And now we find the reciprocal by turning the fraction upside down. And therefore the reciprocal of 0.2 is 5. As for the next statement, we are supposed to find a prime number between 90 and 100, and the only option for that is 97. In part B of this exercise, from this list, we are supposed to write down an irrational number. An irrational number is a number that cannot be expressed in form of a fraction. 7.5 is obviously a fraction. An ending decimal number can also be written as a fraction, in example 6/10. The same is the case for whole numbers. We can just write 1 for the denominator. And the square root of 9 is positive or negative 3. Again, a whole number, which similar to 8 can be written as a fraction. Therefore, the square root of 7 must be the irrational number. Next on to exercise 8, where we can find the equation that a equals b squared over 5c. And we are supposed to find b when a equals 5.625 and c equals 2. So in step 1, we will work with this equation and rearrange it for b, since this is what we have to find. And this is done by firstly multiplying both sides of the equation with the denominator 5c. And now to eliminate the exponent 2, we take the square root on both sides of the equation, leaving us with the expression that b is the same as the square root of 5c multiplied a. And at this stage we substitute the variables for their corresponding values as mentioned within the exercise, and therefore we can conclude that b is either positive or negative 7.5. In exercise 9 of this exam paper, without using a calculator, we are supposed to work out the expression 2/3 divided by 1 and 3/7, and we are supposed to show all of our working, giving our answer as a fraction in its simplest form. So to start here, we will convert this mixed number and turn it into an improper fraction using the method provided. Thereafter, we should remember that we can divide two fractions by one another by multiplying the first fraction with the reciprocal of the second fraction. Then we can simplify 2 and 10 by dividing both of those with 2, and thereafter we simply multiply the numerators and the denominators respectively and receive our result, which is 7/15. Next on to exercise 10, where in part A we are supposed to write 0.00654 in standard form. To achieve that, we can count by how many place value holders we have to shift the dot until it's just right from the number 6. So this is the case for 1, 2, 3 times. Since we are moving the decimal point to the right hand side, we will need to work with a negative exponent with base 10. Therefore, this number can be rewritten as 6.54 multiplied by 10/-3. In part B of this exercise, the number 1.467 multiplied by 10 to the power of 102 is written as an ordinary number. We are supposed to write down the number of zeros that follow the digit 7. To write 1.467 as an ordinary number, we have to shift the decimal points for 1, 2, 3 placeholder values to the right, which means we'll have to work with a negative exponent with base 10. Therefore, 1.467 can be rewritten as 1467 multiplied by 10 to the power of -3. And then we simplify this part of the expression using provided laws of exponents, leaving us with this solution, which is 1467 multiplied by 10 to the power of 99. In exercise 11, we are supposed to write the following number as a fraction in its simplest form. Those dots mean that those numbers are reoccurring. Since it's two numbers in succession that are reoccurring right after the decimal point, our denominator is 99, and therefore the numerator must be 4. In exercise 12 of this exam paper, we will be working with set theory and Venn diagrams, whereby the entire set consists of integers greater than 2, set A prime numbers, set B odd numbers, and set C square numbers. In the first part of part A of this exercise, we are supposed to describe the type of numbers in the set not B intersect C. Not B means that our numbers cannot be odd, so therefore there must be even, and we intersect this set of numbers with the square numbers, meaning that all of those numbers that are represented by the set are even and square. In the second part of this exercise, we're supposed to complete the set labels on the Venn diagram. And looking at all of those sets A, B and C available, we should realize that the smallest set of numbers here is represented by set A, which is the prime numbers. So to approach this, we should firstly remember that there is no prime number that is at the same time a square number. So therefore those two entities must be separate from one another. So we would encounter 1 here. Therefore, we can conclude that set A, the prime numbers, are a smaller subset of the odd numbers. And as previously mentioned, square numbers are not prime numbers. Therefore, they must be located here. Next, on to part B of exercise 12, where we're supposed to shade the region of not D unified with the negation of E intersect F. To approach that, we will first take a look at the expression within the brackets. So the set that is represented by E intersect F is this one here, but we should not select this one, but everything that is outside of it. For this, I have used the color red. Thereafter, we need to unify this set with everything that is not D, which is the same as the previous set, except for the addition that not D is also this part of the Venn diagram. Therefore, our solution is this area in the middle. Next, on to exercise 13, where we are provided with the following diagram that's not drawn to scale. And it's stated that A, B, and C are points on a circle with center O, that DA and DC are tangents. Therefore, I inserted the right angles, and angle ADC being 44 degrees. We are supposed to work out the value of x. To find x, we will firstly have to determine the angle AOC, and from there exploit our knowledge about circular theorems, this particular one being provided. So to determine this angle of the kite DAOC, we just subtract 44 and 2 times the right angle from 360, providing us with a solution being 136 degrees. According to aforementioned circle theorem, the angle AOC is double the size of the angle x, so we will substitute angle AOC for 136 degrees and then rearrange this equation for x in order to determine the size of that particular angle, which is 68 degrees. Moving on to exercise 14, where we are provided with a diagram that shows a trapezium, and the trapezium has one line of symmetry, meaning that we are working with a symmetrical trapezium. We are supposed to work out the area of the trapezium, which is generally done employing the formula highlighted. A representing the bottom base and C its parallel line. We already know the values for H and for C, which means that in order to find out the area of the trapezium, we need to figure out A. A is represented by the equation C plus 2x, since this line being is opposite to line C, so it means it has the same length, and as our trapezium is symmetrical, both of those lines that we will call x are also of the same length. X can be determined by looking at one of the right triangles. We are provided with an angle and its opposite side, x representing the adjacent side. So when we work with this constellation, we know that we are working with tangent. So at this stage, we will rearrange the equation for x, since this is the value that we are looking for, and substitute h for 18.2. Therefore, the approximation of x correct to 2 decimals is 9.62 centimeters. Now we can revisit this equation here and insert the value for C, which is 15.4, and the one of x, which we have just determined, leaving us with a solution that the length of A is 34.75. And in a final step, we can now substitute A for its value that we have just determined and can conclude that the area of the trapezium is approximately 456.40 centimeters squared. Continuing with exercise 15, we are here supposed to complete the table showing information about congruence of pairs of triangle. The first 2 rows have been completed for us, and all diagrams are not to scale. Taking a look at the third pair of triangles, we can see that both of them contain the angle 35 degrees and also the side length of 7 centimeters at the correct side of the angle, which is also the case for the other side, which is of the same length, namely 6.5 centimeters. So since we are working with the congruence criterion of an SAS triangle, meaning that we are provided with the length of one pair of sides including the angle and all of the values of the length and of the angle being the same, we can conclude that this pair of triangles is indeed congruent. Concerning the fourth set of triangles, all of the side lengths are provided and also the same and also within the same orientation. Therefore, we can apply the SSS side criterion and conclude that this pair of triangles is also congruent. As for the final pair of triangles, we are firstly provided that both of them have a hypotenuse of the same length, 5.2 centimeters, whereby the obtuse angle of one triangle is 35 degrees and that of the other one 65. So we need now to ensure that the remaining angles are also of the same length, and we can see that this is not the the case. The reason being that the interior angle sum of a triangle is always 180 degrees. Here we have a right angle, same to the other triangle, so we subtract 90 degrees from it, and here we will subtract another 35 degrees from it, and then realize that we do not receive 65 in return, but rather 55 degrees. So since those two angles are not the same, we can conclude that those two triangles are not congruent. Moving on to exercise 16, where we are provided with the coordinates of 2 points A and B, and in part A of this exercise we are supposed to find the length between those points. This can be determined using the formula provided, leaving us with the solution that the length AB is approximately 8.94. In part B we are supposed to find the equation of the line AB, for which we will have to find two things. So in order to find the equation of the line, we will have to find the values of m being the gradient of the line and c representing the y-intercept. The gradient is determined using the formula provided, and we can conclude that it is -2. Thereafter we will pick either the coordinates of point A or of point B to substitute their values for x and y within the formula. In this case I've opted to go with the coordinates of point A. So to determine c we need to firstly plug in all of the values for the other variables, namely y, x, and the gradient m. From here we simply need to rearrange our equation for c, providing us with the solution that c equals 17. Now we piece everything together and conclude that the equation of the line AB is y equals -2x plus 17. Next on to exercise 17, where we should find the gradient of the line that is perpendicular to the line 3y equals 4x minus 5. In step 1 we will rearrange this equation for y. This helps us in easily determining the gradient of that line, which is 4/3. Now to find the gradient of the line that is perpendicular to this gradient here, we will simply employ the formula provided, letting us conclude that the gradient of the perpendicular is -3/4. Next on to exercise 18, where we are provided with two functions f and g, and we are supposed to solve the equation f of g of x plus 1 equals g of f of x. To do this, we will firstly determine g of x plus 1, and to do this we will take a look at g of x and replace every x for x plus 1. Thereafter we can simplify this equation down to x plus 5. Now we will plug in x plus 5 for all of the x's in f of x. Therefore we have to square x plus 5, take away 25, and equate this with g of f of x, meaning that we will have to substitute x in g for x squared minus 25. Thereafter we simplify this equation for as much as possible and rearrange it for x, letting us conclude that the solution for this equation is x equals -2.1. Moving forward to exercise 19, where in part A we are provided with the following diagram, and it's said that it shows a shape made from an equilateral triangle ABC, equilateral meaning that all of the sides have the same length, and a sector of a circle. Points B and C lie on the circle center A, and the side length of the equilateral triangle is 12.4. We are supposed to work out the perimeter of the shape. So firstly we will try to determine the arc length. So to determine that, we will subtract 60 degrees from 360. The reason being that we are working with an equilateral triangle, and for equilateral triangles we know the facts that all of the side lengths of the triangle are the same, and so are all of the angles. And since in the triangle all of the angles are 180 degrees, dividing this by 3 provides us with 60 degrees. Therefore, the angle BAC has the size of 60, meaning that 360 minus 60 provides us with the angle of the circle. From here we can then determine the arc length of the circle sector and add to it 2 times the side length of the equilateral triangle. This will in the end let us conclude that the perimeter of the shape is approximately 77.33 centimeters long. In part B, we are provided with a diagram that shows 2 sectors of a circle, sector 1 and sector 2, whereby the major sector is shaded and the area of the major sector is 74.5 square centimeters large. We are supposed to calculate the radius of the circle. In step number 1, we will have to determine the angle of the major sector, the reason being that for this sector we also know the size of its area. Therefore, its angle is 319 degrees. Thereafter, we can plug in those values into the formula for determining the size of the area of a circle sector as provided. In step number 1, we will rearrange this equation for r squared and then take the square root on both sides of the equation, which delivers us the result that the radius of the circle is approximately 5.17 centimeters long. Next on to exercise number 20, where we are supposed to expand and simplify the following 3 brackets. brackets. In step 1 we will expand the first 2 brackets, then we are going to simplify the expression within the newly created first bracket, and from there we will again expand those 2 brackets and come to the conclusion that after simplification that the original expression can be written as 2x cubed plus 7x squared minus 7x minus 30. Next on to exercise 21, where it's stated that the force of attraction F newtons between 2 magnets is inversely proportional to the square of the distance d centimeters between magnets when the distance is 1.5 centimeters and the force 48 newtons. In A we are supposed to find an expression of F in terms of d. To set up our equation we need to keep in mind that it is stated that the 2 magnets are inversely proportional to the square of the distance, and whenever we see inversely proportional our arguments needs to shift into the denominator. Now to determine k we will simply plug in the values for d and for f and rearrange it for k, which has the value 108. Therefore, we can state that f equals 180 over d squared. On to part B of exercise 21, where it said that when the distance between the 2 magnets is doubled, the new force is n times the original force. We are supposed to work out the value of n. So in step 1, we will multiply the force by n. And it said that this should lead to the distance being double in size. Therefore, doubling 1.5 provides us with the value 3. In the first step, we will simplify our expression and thereafter perform a cross multiplication in order to eliminate the denominators on both sides of the equation. And in the final step, just divide both sides of the equation with 2, providing us with a solution that n is 1/4, which is the same as 0.25. Next on to exercise 21, where we are required to simplify the fraction 2x squared minus 5x minus 12 over 3x squared minus 12x. What we will try to attempt first is to factorize the numerator as well as the denominator. As for the numerator, we should be able to spot that both of the summands of the numerator contain the factor 3x, and using the method provided, the numerator will be rewritten to facilitate factorization. After rewriting the numerator accordingly, we can there also spot that the first 2 summands contain the same factor 2x, and for the latter 2, both of them contain the factor 3, leaving us with 2 equal factors, which in turn we can again factorize. And in the final step, we can simplify our fraction by dividing the numerator and denominator by their common factor x minus 4, leaving us with the conclusion that the simplified version of the original expression is 2x plus 3 over 3x. Having come to the penultimate exercise of this exam paper, exercise 23, here we are supposed to find all the solutions of the equation for sine x equals 3, for x being within the interval of 0 and 360 degrees included. In the first step, we rearrange this equation for sine x and use our pocket calculator, providing us with a solution that sine x equals 3/4 translates to 48.6 degrees. Since sine contains positive values for the first and second quadrant, working with reference angles as provided, we receive the second solution being 131.4 degrees. Lastly, we are supposed to solve the equation 1 over x plus 1 plus 9 over x plus 9 equals 1. In step number 1, we will be performing a cross multiplication, which ensures that we can write those 2 separate fractions as 1. In the next step, we multiply both sides of the equation with the denominator, and on the right-hand side of the equation then expand both of those brackets. Thereafter, we will simplify both sides of the equation and rearrange it for x or x squared. In this case, it's x squared. And after taking the square root on both sides of the equation, we can conclude that this equation has a solution for x equals positive or negative 3. I've been your host Marco from Planet Maths. Should you derive any value from my videos, please consider to leave a like, comment and subscribe. Thank you for watching. Cheers!